The excessive use of antibiotics is leading to the evolution of antibiotic resistance in bacteria. Farmers add antibiotics to animal feed because it helps the animals gain more weight. Frequently, doctors overprescribe antibiotics as patients demand or want a treatment, sometimes for a virus for which there is no treatment. Patients sometimes don't complete treatments. And if you take an antibiotic and don't take all of it, you'll allow mutant organisms, let me finish writing this, that are killed more slowly to survive and multiply, that will aid in the evolution of bacteria that's not killed at all. Currently, we have problems with antibiotic-resistant TB, staph, MRSA, and malaria. You'll see recently in the news they've been talking about super gonorrhea. There's antibiotic-resistant gonorrhea now, and it makes it very difficult to treat. We rely on the ability to use antibiotics to do a lot of our elective procedures. It'll become much more dangerous to, say, have your wisdom teeth taken out if we don't have antibiotics that are effective that you can take. You could die from a simple procedure like wisdom teeth. So scientists are continually trying to come up with new antibiotics. Diploidy and balancing selection will preserve genetic variation. So because we're diploid, most animals and plants are, we preserve variation by hiding recessive genes. So recessive alleles are hidden and they prevent the population from becoming uniform. These hidden genes may not be favored currently, but serve as a pool of alleles that might be used in the future. We also find that sometimes there's a heterozygote advantage, where the heterozygotes are favored. This will preserve an allele in the population. And the example that we always use for this is sickle cell. If we look at the prevalence of sickle cell, correlates strongly with the prevalence of malaria, because if someone has that sickle cell, only one copy of the sickle cell, they are resistant to malaria. 2 copies of sickle cell make you very, very sick. And so you want your population to have just enough sickle cell alleles for the people to get have some of it. Now, natural selection will not make perfect organisms. And this is because selection has to act on existing variation. And it's limited by historical constraints. Evolution must build on what's already there. Old structures can be adapted, but the adaptations are often compromises. For example, feet that make excellent paddles don't make good feet for walking. And what we have in evolution is chance and natural selection and the environment interacting. Now, if you'll note, we skipped the Hardy-Weinberg equations. This was section 1310 and 1311, and you're not responsible for that information. I will see you next week.